Hello, this is Ben Geisler coming at you for another round of bouncing ball madness. We should be working off of the previous advanced ball tutorial, so if you haven't gone that far yet in Unit 1, try to get that far. And I've still got this thing called Hello World here. First thing I'm going to do is I'm just going to change that. You can just right click on and rename it. I'm going to just call this bouncing balls or something, so it's something different. It's kind of annoying me that it's called Hello World still. Alright, now it's bouncing balls. Alright, now I'm happy. Next up, what I need to do is uh, basically we're going to add a rectangle type, and this rectangle type is going to be our bounds of the ball. Before we were kind of talking about bounding boxes and how it would be 32 by 32. Well, that is going to be the case, but I want to be able to have a rectangle to basically be able to move around the screen, because my end goal is I'm going to have it colliding off the walls, and in order to do that I need a rectangle to do it. So add rectangle my rectangle there, and then down below we're going to say my rectangle equals new rectangle, not 128, but 128, 128, 32, 32, and that's just kind of putting it just off to the right and down a little bit, and with size 32, 32, and then just formatting it there. Next thing I'm going to want to do is, well, actually, I'm going to just call ball velocity instead to make things easy. And then I'm going to set these to 3f, meaning 3 floating point values, so 3.0 basically is what that is. I'm going to set that to 3, and then velocity dot y to 3, and these need to be capital. So basically I'll be setting each of the velocities to 3. What I'm going to do from now on is I'm going to update just the x with the velocity. That way I can actually start to make this more of like realistic physics. And I need to cast that to an int because my rectangle.x is a int, so I need to be able to use that as an int, and do the same thing with y. And then I also want to draw the rectangle now instead of the ball. And next up I'm going to test to see if the rectangle is within bounds. Last time we kind of did this hacky thing where we were checking if it was, well, this thing first of all changed the direction that it was going. That kind of simulated a bounce, but that's actually not what I want to do. I want it to just instead, oh, and this, we need to change this to y. Remember to change that in your code. Instead what I want to do is I want to say my rectangle.x less than 0. If that's true, then actually I'm going to, basically if this is less than or equal to 32, then I want to say my rectangle dot x equals 32. And actually, while I'm at it, this 32 number is getting really, really annoying. I think what I'm going to do is go ahead and bite the bullet and create what's called a define. Basically, I'm going to put a define up at the top that's the size of my bounding box. So I just say pound define bounding box. Actually, I'm going to call it BB size. So for bounding box size, I'm going to set that to 32. And now everywhere that that number 32 appears, we can replace it with BB underscore size. We need to move this down within namespace, I guess. Okay, forget this define thing. This is not going to work. Instead, we're going to use what's called a const. I'm going to put up here public const int, and I'm going to call it bb size equals 32. So now bb size can come down here. Okay, try that again. Public const int size is 32. That's what we actually want, is a public const. We're going to actually call this bb underscore size. And then we replace that 32 with bb size here. Here. Yeah, I just got really sick of seeing that bb size business. Here is another one. We're actually probably not going to be using those, but these functions, but I might as well just update it anyway. Okay. Okay, so if my rectangle is bb size, and then bb size down here, and that brings us right around back to where we were. A couple more spots. And that should do it. So the next thing we want to do is basically tell if we're outside of the bounds, and if we are, we're going to basically stop. So if my rectangle dot x is plus the bb size greater than or equal to, our screen width is 800. Then we want to say my rectangle dot x equals 800 minus bb size if my rectangle dot y less than or equal to bb size, and all these are pretty much going to be the same except for y, so I'm just going to go ahead and take this, copy it, paste it over what I just wrote because I don't need that. Just change this to y. Okay, so, and oops, we need a bb size in here, not just b size. Okay. And one danger of copying and pasting is that you need to always check the variables you've used. This should be the screen width, which I think we had set to 480. Here's another, probably leave this for you guys to do as part of your assignment, but this 480 and 800, 480 for the height, 800 for the width, is also kind of annoying, so really maybe that should be a const as well, a constant, but I'll leave that for you. For now, I'm not going to worry about it. Also, one thing to note is we want to actually say BB size plus BB size, because this second BB size is the size of the walls. So when we're doing our comparisons, we have to check against that as well. So we say BB size here, and then subtract from here as well. So now let's run it and see how that works. We see it going along, and then it stops. So that's kind of already a little more accurate than we had before. So next up, notice that we've got this line here that says myRectangle.x equals BB size. It's kind of stopping at that, that far border along the x. And we don't want that, or we don't want it on the y either for that matter. So for the myRectangle.x less than or equal to 0, or BB size in this case, 32, we actually want to change that. So we're going to change that. So we want to change that to velocity.x. We're going to basically change the velocity here. So no longer are we going to be doing this thing where we tell it to stop. We're going to change it to velocity dot x equals, we want to go the opposite direction, so we're going to say negative velocity dot x, and that will go the negative vector direction there. We want the same for the right hand of the screen here, this side over here basically. So we want to go velocity dot x equals negative velocity dot x, and we also want that for the y's. So velocity dot y equals negative velocity dot y, and down here velocity dot y equals negative velocity dot y. One other thing that's bugging me just really quickly to fix is this needs to be consistent. There we go. Just kind of pet peeve there. Okay, so what this should do is start bouncing around on the screen for us, because we're basically subtracting, we're taking the negative 1 times the current velocity in any direction that we go. Oops, misspelling. So we're taking the negative 1 times the current vector for the velocity, and that should give us what we want. And there we go. So that's bouncing all around now, and you can probably still click it. Oh no, I think we might have taken that code out actually. The teleport code, it looks like we need to fix that. Yeah, if you look up here, we actually are, in the update, we're checking against the ball pause, which we are no longer using, so we need to do some cleanup here. First off, this should be my rectangle. Oh, gotta close this before it lets me. So this should be my rectangle. This should be my rectangle. And that should give us what we want. But not quite, because we didn't change what? Yep, you are right. We did not change teleport ball. We're just doing ball pause.y here. So we gotta do rectangle my rectangle actually. My rectangle, darn it. Where did our teleport go? Oh, if we ever forget where things go, that's actually a good time to bring that up. We should be able to look at our class or our reference here. Never mind that. Let's just do it the old-fashioned way. Scroll up. Alright, here we are. Rectangle. Y. Alright, now that should do it for us. And yep, indeed, I can click on this guy and it teleports. So next, I think the thing I want to do is have this going random directions. Have the ball start going random directions. And to do that, well, first let's clean up some things. We don't need this ball pause anymore. Where else does that appear? I guess we've... Oh, simple update, we don't need that anymore. And we don't need to call it down here either. I'm kind of violating some principles here of object-oriented, which we'll talk about once we've covered those in the slides a little more. This is kind of a quick and dirty ball game. When we get to the mini project, I'm going to show you kind of how to go about some of these things better, like how to go about some of these update loops better and stuff like that. So for now, let's try to add random directions. Okay, since we're going to be using random numbers, we want to have a random variable introduced at the top here. Maybe just under our velocity. Oh, we don't need updater anymore, by the way. Okay, so where were we? We're going to be adding a random, so we'll call that random. Random is the random number generator for x and a, and I'm just going to call that my random. And we have to say equals new random right there. So now next up, so what we're going to do is we're going to make a new function. You'll notice that we've got override void initialize, override void load content, unload content, teleport ball. We're going to add yet another one. This one we're going to call random load. We can make it private. Some of these other operations we've been loading could also probably be moved off to functions. That's the kind of thing we'll be covering in future classes as we learn a little more about C#. So actually, we want to say myrandom dot next with a max of 4. So that's going to go 0, 1, 2, or 3, basically. And then we want to go up to or down to the next section down here, and we want to say if random equals 0, then I'm going to say velocity dot x equals 3f is fine. And velocity dot y equals 3f. And we need a bunch of these. And actually, this would be a perfect situation for a case statement, but I'm just going to do this the old-fashioned way with a bunch of else's, and finally an else down here. So basically the way this works is if the random number is 0, then do this. If it is 1, then we want it to do something. Otherwise, if it's 2, we want it to do something else. Otherwise, it's going to be 3. If it's 1, we're going to have it be the negative velocity. If it's 2, we're going to have it be negative in x and positive in y. And if it's 3, we're going to have it be negative in each. So that's our random load. Now we need to call our random load from load content. Load content up here, so we're going to call random. And that should give us what we want. It's going to start everything out in a different direction. Hold on a second. Let's try that again. Yep, that was a different direction. There's a different one. And actually, just to test this, what I'm going to say is every time it's clicked, it changes directions. That will be kind of fun. Okay, teleport ball, then random load. Why not? Then random load. Okay. Okay, so it is changing directions every time I touch it. So that's kind of fun. It's going whatever direction we tell it to go, and that's kind of cool. Alright, so that completes this part of the tutorial. Oh no, it doesn't. There's a couple things I wanted to mention. The challenge assignment this week for extra credit actually is going to be, the actual assignment is already posted. It's some basic C#, but for extra credit we would like you to attempt to put a score in the game, as well as put putting more than one ball in the game. So let me give you some hints about both. For score, obviously you're going to need a score. So you can create like int score, for example, up here. Actually, let me stop debugging. So call like int score, for example. Let's just say int score here, and then every time it clicks on that inside of the teleport and random, you know that's been clicked here. You could increment the score. As far as displaying that, as far as that goes, we can go back to the previous, you can check out the previous videos on how to do a draw call to the hello world. But just as a hint, it is drawstring, remember. So spritebatch.drawstring. We've already got the sprite font actually loaded up here somewhere in the load. Yeah, sprite font is right there. And so in your sprite batch begin, this is where you would want to do the drawing, and that is sprite batch dot draw. Debug again. Sprite batch dot drawstring. Oops, I'm in the wrong one. Sprite batch dot drawstring dot drawstring, and that's where you give it your parameters. So that would be, you would draw that every time with the score. If you feel like it, you can put it in some kind of nice spot on the screen and kind of like move the entire screen in so that you can maybe put the score up top, or perhaps put it along the right hand side or something like that if you're ambitious. If you do that, you're going to need to change all of these screen width settings so that the not only so that the walls can draw correctly, but so that it can bounce off of the correct places. So you would have to change that. Also, what you'll need to do is create more than one ball. So to do that, in addition to adding score, will be a little bit of a challenge, but should be definitely possible. You will, and if you do one but not the other, we'll give you partial extra credit. But basically, to do that, you would create like a ball 2, like a texture 2D. Actually, you wouldn't need. I'm sorry, no, you wouldn't need that. You wouldn't need another texture because you'll just use the same one, unless you want a different one. If you want a different one, then you would, like a purple ball or something. You'd say a texture 2D ball 2, and then you would just load the appropriate ball 2 PNG texture for that, and then you would basically make a My Rectangle 2, and you would go through and just copy everything that the original ball has, like velocity. You would make that velocity 2, and anywhere that stuff is changing, you'd probably want to change. You'd probably want to change the starting position to something other than 128, 128. So we load these balls in different spots. You might want the velocity to be a little bit different. Maybe you even want the random load to go a little bit differently. And that is how you would do that, and create as many balls as you feel like. And that's about it. But basically, also just to let you know, what I just described is a little bit of a pain because each ball needs to replicate all of these variables. Next time around, once you guys kind of understand classes a little bit better from Dr. Bresnay's lectures, I will make a new class called ball that will include the texture for the ball, the rectangle for the ball, the velocity, all that stuff. And then what we'll do is we'll instantiate balls inside of this, and you'll see that's a lot easier then to create multiple balls. And that's really what we should be doing. That's really how we should be thinking of this. But for now, this was an easy way to get you started, and very simple to get going. It kind of gets you up and running really quickly, and we can discuss the kind of more fancy ways of doing it later. For now, this gets you going, and good luck with that. Extra credit again if you can manage to get multiple balls as well as a score. All right.